This hopefully is one of several videos that will relate to the structural checking of certain timber members. Although lots of timber members will be covered in tables, the tables don't identify the variations that happen in real life, and sometimes it's even quicker to go through this procedure than start looking at tables. At least you know, if you do it this way, that you've been specific to the situation. So, floor joists, mostly taken from the tables, but the tables don't include the following. Like I've just said, non-standard centres, floor joists with partition loads, and staircase trimming. We won't do anything on staircase trimming because that generally involves point loads, and that'll be subject to another video. It's not difficult, but it's just beyond the scope of this. So why floor joists? Like I said, it's a good place to start. They're simple, everybody understands them, so we don't have to worry about anything other than the basic structural principles. They're only subject to 2 loads maximum, floor and partition, and 9 times out of 10 it's just the floor, and we're looking at a non-standard centres, say 300 centres or something similar. And you can't ask a builder to provide structural calculations for double floor joists. So it's something that, it's within the realms of anybody really to check. And it's where I started. That's exactly what happened to me. It wasn't a double joist. It was a builder wanted to put floor joists alongside the existing flat roof joists that he was going to build over and form a first floor extension. So the existing joists were 150 by 50s with 6 by 2s in old money at 400 centres, and he effectively wanted to put floor joists in between. So the floor joists now, the 150 by 50s were at 200 centres, and that wasn't in the book, and I was in trouble, and I didn't like being in trouble even at a young age. And I was fortunate. I went back to the office, and my manager sat with me all afternoon, showing me how to design a floor joist manually. So that's where all of this started. Right, the loads that floor joists are subject to are exactly the same loads as any structural member is subject to. The only load that we haven't identified here is wind loads, and it's not subject to wind. The floor joists aren't subject to wind loads. So the 2 loads that we are looking at are permanent loads. Permanent loads are dead loads in old money, and it's just the weight of the structure. So it's in the case of a floor joist, it's the floor decking, bit of insulation in between for sound insulation these days, or it may have thermal insulation if the floor's over a garage. The weight of the floor joists themselves, the plasterboard and the finish, generally a neat gypsum skim. So that's the permanent loads for a floor joist. The variable loads are the people moving about the floor, furniture, and any load that's not affixed to the floor structure. So if you have an exercise bike in there, for argument's sake, that's a variable load. You can move that any way you want. It's a variable load. This is where sometimes floor joists are overloaded and dangerous structures occur. Hoarders, for argument's sake, who just can't throw anything away, and you go into a house and the floor joists are in distress. They are over deflecting, and you open the room up and it looks like a storage. It looks like a storage warehouse. It's the room is just filled up with stuff that's been collected over a lifetime, and some people can't throw it away. It's an issue that it's very difficult for them to address. So that's a situation where variable loads, we can't cover every situation, but 99 times out of 100 they are well within the loads that the loads of general use. So here's the permanent loads for floor joists. The floor decking can be anything between 10 and 30 kilograms a square metre. The 10 might be just 12 millimetre plywood, and if the floor joist centres are close enough, then that's absolutely fine. If it's a square edge board, as you're well aware, it will need it needs some kind of continuity for fire resistance, because it's not tongue and groove, and so you would just pick up all of the edges on 50 by 50 timber noggins, and that would deal with the fire resistance aspect, and that's the case with all square edge boardings. Floor joists between 5 and 15 kilograms a square metre. That's from the difference perhaps between a 4x2 joist at 400 centres and an 8x2 joist at 300 centres. But that's all calculated in the spreadsheet. Insulation, just an arbitrary 3 to 5 kilograms a square metre, and even that's high. Ceiling lining and finish between 5 and 50. Between 15 and 50. That the 15 half-hour fire resistance, 30 1-hour fire resistance, 50 perhaps where you have 3 layers of plasterboard and various different products to resist the passage of airborne and impact sound. So that's where the variations occur. So generally the total's between a minimum of 35 kilograms a square metre and 100 kilograms a square metre. It's generally in that ballpark. So it's between 0.35 of a kilonewton a square metre and 1 kilonewton a square metre. Variable loads used to be called imposed loads, but variable loads is a better description. That's exactly what they are. They can vary. Variable loads are tabulated in EC1 for different building uses, much the same as purpose groups in ADB. These are used to define the fire loads. That's what's behind the purpose groups. So if you have an office purpose group, then there will be a fire load behind it in megajoules a square metre. And variable loads is exactly the same. For domestic single occupancy dwellings, the variable load is 1.5 kilonewtons a square metre. Right, there is a spreadsheet that does all of this for you and picks everything up for you. And the spreadsheet is a list of of 11 the most popular constructions in domestic single occupancy buildings. Each loading has variables like we've just been talking about in previous slides to take into account the different materials and performance requirements of each structure. Example would be a 30-minute fire resistant floor would be lighter than a 60-minute fire resistant floor, and those amongst you would probably spot the spelling mistake. Well, not a spelling mistake. That it's text recognition, and obviously got it wrong. All the way to the materials are pre-programmed in. It's just a pure selection process, so you don't have to remember, the weight of a 18mm chipboard floor. That's all in there. Once a permanent load has been established, only the centres of the joist will be required to be input. At this stage, we're not worried about spans. This is just pure unit area loads. This is a spreadsheet that you will see when you open it up, and in cell B2 you'll see clear all entries. Press that and that clears all of the entries, otherwise you may be calculating values from a previous use. So that's the first thing you do. Then we move down to cell 54, and that's floor constructions. And if you look on the right hand side where the numbers are actually highlighted, those are the numbers where there's variations. So if you clicked on the 18mm chipboard, you'll see a drop down menu and it'll give you various different floor deckings. Same thing goes for the floor joists. It'll give you various different sizes of floor joists, which will obviously change the weight. The insulation, you just manually put that in, but I've just stuck it in as 3 kilograms a square metre, and if that's 100 millimetres of mineral wool that's used for sound insulation, so be it. In this case, I've shown 2 layers of plasterboard, and but again, that's variable. There'll be 1 layer, 2 layers, 3 layers, 4 layers. Depending upon whether it's a fire resistance or a sound resistant floor. The first permanent load will be the total of all of the permanent load items, and it's in kilonewtons a square meter. So it's basically the total of the constructions. That's multiplied by 9.81, which is acceleration due to gravity. That changes kilograms to newtons, and then you divide that by 1,000, and that converts newtons to kilonewtons, and that's basically why it goes from 53 kilograms a square meter to 0.52 of a kilonewton a square meter. As we've already figured out, the domestic variable load is 1.5, and there is other variable loads in there. For office, for argument's sake, is 2.5, shop is 4, mezzanine floor for industrial uses is 5 kilonewtons a square metre, but we're just using the domestic one. Right, once you've ascertained the weight of the structure, i.e. you filled in the 1, 2, 3, the 4 areas, 5 including insulation, then what we then need to do is to fill in the attributed load. Now basically what you put in there is the centres of the joist. So if the centres of the joist is 200 mil centres, it would go in as 0.02. If it's 400, 0.04, and in this case I put in 0.6, which is 0.6. And so that's the attributed load. The next thing you need to do is to, if you look at the bottom of the spreadsheet, there is various other spreadsheets. And the reason that the attributed load is in orange is because the single UDL is in orange. And so if you are filling that fella in, then you would use the single UDL load. There's other options with this particular spreadsheet, but that's the only one we'll talk about at the moment. So if you press the single UDL, and you will be shown this sheet. Now, in L1, in the top right-hand corner of the spreadsheet shown on the slide there, there's a yellow slide with select. If you press the little white square within that, it looks like a speaker, vertically, or I don't know what it looks like, and I don't know what it's supposed to depict. But if you press that, you'll see that drop down occur. And if you look below the search box, you'll see 4 dialog boxes, select all, 0, X and blank. Make sure that only the select all and the X's is selected. That way you won't get any information that's irrelevant, because there's an awful lot of information in this spreadsheet, and all we want is what's relevant to you. Once you've done that, then this will appear. So you have your floor construction, you've got your permanent action, which is your floor joist spacing, which is the 0.6 multiplied by the total permanent load, and you will see the variable action again, the spacing of the joist multiplied by the variable load, and they will give 2 numbers. And these are the only two numbers that you need to go into Eurobeam. So the white numbers, the 0.031 and the 0.9, they are for Eurobeam. And if you got Superbeam, then you would use the bottom one, the permanent plus variable, which is 1.2 kilonewton a meter. So you only need for Eurobeam to enter to get an answer out. You only need the total permanent at 0.31, the total variable at 0.9, and the span. Obviously, the span. And the span is basically centre to centre of the supports, or generally the clear span, whatever it is from wall to wall or wall to beam or whatever you check in, plus 100 millimetres. And that will be the span. So if the clear span is 3.1 metres, the effective span, that's what basically you're checking, the effective span is 3.2 metres. And once you've got there, we will then move on to Eurobeam. Right, before we go on to Eurobeam, we're going to go through the spreadsheet, which is pretty simple and straightforward. There it is, loaded on the desktop for ease. Don't know what the exclamation mark's for. And here it is opened up. Now, it's opened up in the wrong sheet. It's opened up in the single U. I need you to be in the load sheet, because that's where all of this lot is. And we're looking at a previous project. So like I said initially in the slides, we need to clear all entries, otherwise the previous data will contaminate it. This is the spreadsheet, and it has all the different load-ins that you're likely, all of the different load-ins of different elements that you're likely to come across. So a normal roof, a lean-to roof, ceiling, floor construction, block and beam, flat roof, balcony, internal wall, lightweight, masonry, lightweight, cavity wall, timber frame wall, solid wall. Can't think of anything else. Never needed anything else. But that's the spreadsheet. We're going to go down to the floor because we're only going to do a floor joist. And there's the floor construction. And on cell 54, and anything that's highlighted in these boxes here is subject to a drop-down menu. So there's the drop-down menu, and there's a different deckings, floor deckings that you could have. We're going to go 22mm chipboard because we're going to, no, I'll tell you what we'll do a proper job, 15mm tongue and groove. The span might be around about 4 meters, so we'll estimate 200 joists. Insulation, now if I'm going to use 2 layers of 12.5 insulation, that's generally say for argument's sake, a garage ceiling, a room, or for the floor of the room over a garage. So that might be 5 kilograms for the insulation per square meter, but that's overestimating. I've got 2 layers of plasterboard in there, could quite easily be 3 layers or 4 layers, but there we go. We're going to go 2 layers. We said 2 layers, didn't we? And that will calculate out the total load for the element, which is 54 kilograms a square meter. We're going to convert that into kilonewtons a square meter, and we do that by multiplying it by 9.81, which is acceleration due to gravity, and we then that will give us newtons, so it will give us roughly 530 newtons. And then we divide that by 1,000 to get that into kilonewtons. So 1,000 newtons in a kilonewton, and that gives us 0.53 of a kilonewton. So that's the only bit of maths between that, and you can see it there. It is there. One cell multiplied by 9.81 divided by 1,000. Then we go on to the variable loads, and as we've already gone through, we're going to use 1.5, but there's office, which is 2.5, with shop, which is 4, mezzanine floor in a industrial use is 5, but we're going to use domestic. The next thing you need to fill in is the attributed load. Now for a floor joist it's going to be, in this case we said it's going to be 600, so if we put 0.6 in there, and like I said earlier, that attributed load, single UDL. Each leaf UDL is if you're filling in the green, but we're not going to be doing that. So attributed load 0.6, press the single load. And again, as I stated, first thing we're going to do, we're going to go up to this box here, and we're going to press that, and we're going to ascertain this box here. See, if this box is filled in, if all the ticks is there, you get a lot of information that you don't want. The numbers are right, the numbers won't change, but you get a lot of rubbish in there that you don't want. So select that, so those two, and you'll get only the information that you need. Now this is the information you're going to need to take into Eurobeam. The total permanent load is 0.32 kilonewtons a metre, and the total variable is 0.9. If you look above, you'll see how it's ascertained. The 0.6s are your centres, and on the permanent, the 0.53 is the permanent load, and the 1.5 is the variable load. They're multiplied up to create an action. So the loads we calculated on the previous sheet, the second you make it into a load that's going to be imposed onto a beam, it turns it into an action. If I give you the right terminology, at a later date, you should be able to figure this one out. Well, this is Eurobeam's opening screen. So when you press the icon on your desktop or wherever you have it, this is the first thing that crops up, and you've got to enter your initials. It won't go any further unless you enter your initials. It is that important. Anyway, once you enter the initials, if you go to the top left hand corner and go to File and then go to New, and a dialog box will open up and you fill in the details of the project or the check. A further screen will then appear to enter the file name. Obviously it needs to be able to dump this information somewhere, and that's basically the idea of that particular file. Right, well, after the file dialog box has been completed, if you have a look at the toolbar on the top left hand corner where it says Open, Save, Summary, Add Beam, you press Add Beam, and then another white dialog box will pop up, and we're going to, because we're in timber, just press the timber button. That will open up two screens. The first one on the left will open up pretty quick, and the second one, for some strange reason, seems to take a little bit of time, but that's the important screen, and like I said, it does take time to load. Now we can even start filling in the details on this loading screen. So where it says beam, you can type in floor joist. The span, if we say that the clear span is 3.8 meters, add our 100 millimeters, and that gives us 3.9 meters. The beam type is timber, so there's no problems there. Print loading diagram, well, this demo won't print anything anyway, so it's pointless going any further on that. Now on this, it has some data already included, and I've left it in the next slide. Really, for timber you don't need it. The own weight, what OW stands for is own weight, and we've already taken into account the weight of the joist. So theoretically you could type over that, but for some strange reason I didn't do it in the next slide. If it was a steel beam, for argument's sake, then you would, if it was a 6x4 steel beam 152 by 89, then you would type in 0.016 there, because that's the self weight of that particular beam. But we don't need to do that for timber because we've already taken the weight into account. So you've filled in the beam and the span, and it's now time to enter the loads. Now, if you look at the table down the column T, that relates to what the load is, whether it's a uniformly distributed load, a point load, or a partially distributed load. We're only going to be dealing with uniformly distributed loads, so at this particular stage, anything's going to have a U in it. The D is the description of the load. I've said D is description, it could mean something completely different. But G is permanent loads, and QA is domestic variable loads, as QA, QB, QC. It's another idiosyncrasy of the Euro codes, but let's play with it. And so any domestic load, and I imagine if you're doing any work on this screen, on this application, everything's going to be domestic. So variable loads is QA. So we've got that. Description, well, I would just put in permanent and variable. It's funny that even this program has as a preset is dead and imposed. Well, dead and imposed is dead. It's of no more, as the parrot sketch is in Monty Python. So let's get used to calling the loads what they are. Then we move across to the column W1. Now W1 is the load, and we extract out that directly from the spreadsheet, and the spreadsheet said that the permanent load is 0.32 and the variable load is 0.09. If once that information's in, then press the apply button. The apply button should be standing out, once you've got the information in. So you press the apply button, and the left-hand side screen has already done its work. It's already done all the calculations. It's worked out the bending moment, the shear force, the deflection coefficients and constants. So all we need to do now is start putting some additional data into it. So what we then need to do is to press the timber button. So if you look at the top right, if the top center, there's 3 dialog buttons there: loads, timber, bearing. We're in loads at the moment, and now we've got to start specifying stuff about the timber. And here we go. This is the final screen, and it determines the size of the member and the strength class and some of the bits and pieces that are relevant to timber. So you'd start off by entering the width of the timber: 47, 50, 63, 75, whatever, and depth 150, 170, 175, etc. They're on drop-down menus, so you just choose whatever you want to choose. The maximum span deflection, L over 250, I would keep that for the time being. The other 2 values relate to cantilevers on either side. Won't worry about them, and don't worry about changing to standard DIMS. Then we go into that dialog box at the left-hand side, which is the strength classes. So basically, you'll only be using C16 or C24, but there's a whole rake of other strength classes in there. The next dialog box on the right-hand side of that is the loading duration, and without going into a long lecture on loading durations, floor joists are medium-term loads. And the next dialog box on the right hand side just says if it's dry and heated, which it generally is if it's a floor joist, but it could be dry and unheated, like for a ground floor, for a ground floor suspended joist, or a joist over a garage, that's not heated. And 3 is exposed, that's exposed on the outside. So for argument's sake, if you've got a lean-to extension, and it's got a recessed porch, and the timber is supporting the roof of the recess, then that will be exposed. So you would flag that one up. Move across again to the left hand side. Flitch beam. No, it's not a flitch beam. Next one is load sharing. Yes, it is load sharing. It's a floor joist. It shares a common load. So floor joist, ceiling joist, rafters, they're all load sharing. Because they share a common load. A single purlin by itself, for argument's sake, would not be load sharing. It would be only one member taking the load. But this is several members sharing a common load, and hence that's why you tick it. And when all that's done, you press the apply button, and everything will occur on the left-hand screen. It's like I said, it's a demo version, so you will get all of the details there, but you won't be able to print it out. You'll be able to tell if it complies or it doesn't comply. If you look in the top right-hand corner where it says depth, there's a question mark on there. That's the design feature. So if you put a question mark in there, it will calculate the shallowest timber member to fit all the criteria, i.e. in this case it would be the strength class, the term loading, the service class for the exposure, and the load sharing. So that's more or less about it. Let's take you through the actual program. And right, here we are, the final lap. Starting off on the blank screen, there's my Eurobeam. So we're going to type that in. And like I said in the presentation, unless I put my initials in there, it won't have it. Usual license agreement, God knows what I've just agreed to. And like I said again, we move up to File, New. It'll then give us a dialog box to fill in. The street. And the job is a floor joist. Okay, so that's enough for that. There's nothing there of any use to you at the moment, although there may be in the future. I'm going to type in there floor joist 3 because we're on take 3, because my wife just opened up a wardrobe while I'm recording and it made a hell of a creaking sound. So there we go. So the screen goes blank. And now if you go to the top dialog box, and there's a load of stuff along there, but if you go to the 4th dialog box along and add beam, and then this sub dialog box will turn up, and we're dealing with timber. So the first dialog box opens up, and this is the loading data input sheet. Everything we're going to do here relates to the loading. Everything that we do here relates to the spreadsheet that we prepared. So we're going to put in what the beam is. It's just a floor joist. And we're going to put in the span, which we said was 3.8, but because we are using effective length, that's 3.9. Well, got carried away there. So 3.9. We'll move left to right. Beam type is timber, although you could have steel or whatever. Put the timber in. These aspects don't worry about too much. I don't even know what auto OW. I know what that means now. Take that away. No, it's not going to do it. I thought it was going to do something. Right. Okay. Now let's look at this table here. We're only going to be using part of it, so there's lots of it that's not real an issue. If we start on the T column, and this relates to the configuration of the load. Now everything we're going to do is a uniformly distributed load. It will take a point load and it will take a partially uniform distributed load. But we're just going to be using U. The D is the description of the load. And as we know, it can either be a permanent load or a variable load. Now G is permanent and Q is variable, and G and Q have been around since the 70s in relation to limit state design. So G is always the dead load and Q is the imposed load. Now what this has done is it's put its own weight, it's put an own weight in there of 0.1. Now that's predominantly for steel, because we have already taken into account the weight of the floor joist. We're not going to put that fella in, so we're just going to type that fella out. Okay, so the first if we go on our spreadsheet, there's our spreadsheet. Total permanent 0.32. So it's G is permanent. Let's put permanent in there. Let's get into good habits. And 0.32. And then the variable is a U. Now it's Q, but it's also A as well. The Q is for variable loads or imposed loads in old money. A just means it's a Euro code thing for residential properties. So B is a commercial property. C might be industrial, but that's what QA stands for. So in this program, it's QA. And if we put in there a variable, check on our spreadsheet again. Total variable 0.9, 0.9, and that's it. That's the loading done, and apply. Now the left hand side is the calculation box. This has got all the structural calculations has already been done, but the beam size is a bit on the big side. I don't think we need a 300 by 50 floor joist over a 3.9 span. And that is because there's some factors in there that hasn't been taken into account. So now we've completed the loading, push timber, and basically I'm going to work left to right, down over. So the width, you put your width in, we're going to use 50. Depth, now if you put in question mark, it will design it for you. If you give it a size, it will check the size, and because we check in rather than designing, I would suggest, if that was the size that was offered to you on site, then that would be the size that you use. Solid, and there is your two options, your C24, your C16. Your loading distribution, don't get into that too much, but as far as floor joist is concerned, it's got to be a medium term load. And then the next dialog box is service class, whether it's dry and unheated, or exposed. Now this particular case will say dry and heated, but it could be dry and unheated, i.e. a floor joist over a garage. That wouldn't be heated. Or it could be exposed, where it's exposed to the elements, i.e. a beam over a lean-to extension, where there's a recessed porch. So there's a bit of a recessed porch in there, and there's a 6x4 timber beam over the top supporting the roof. That's exposed, and then you would press that fella. Back across the left hand side, it's not a flitch beam. Load sharing, yes, it is load sharing. We've got many joists supporting a common load, so it's load sharing. That would also apply to ceiling joists and rafters. Purlins it wouldn't apply to unless there's two together, but if it's just one single purlin, you wouldn't tick that. And to be fair, I don't think you would take it if there was two together. The European code doesn't take much account of that. So it's either load sharing as a panel situation, or it's not. So all the data's in there, and now we can push apply. And down the left hand side is all the data's all been done for us. In fact, it's been done for quite a while, the second you put in the loads. So there's the reactions. Those are unfactored reactions, factored reactions. And there's that little bit about G is dead, QX rather in pause, QA residential. So the QA is the one that we're going to be using. I have no idea what QX stands for, but I'm no expert on the Euro codes, but we can certainly put information into the so it's checked out. That's shear. I would imagine, yeah, it is shear, but it doesn't say so. That's a shear. Then bending. Oh no, there's a shear there. No, what that is, that's data. That's data that relates to the section size and the materials that we specified. Then that's the bending. Then the shear and the deflection. And it's all, and that particular joist is okay. And that's it. It really is as simple as that. Now, if you wanted to print that out, you would press the thing, and somewhere in the, oh no, it isn't, it's here, isn't it? There's the print. But because it's a demo version, you can't print anything out. But there's a print the beam out or print the project out if we end up actually buying the product. And that sums it up. It really is that simple. You go through that procedure half a dozen times and it'll be like clockwork. And hopefully as time goes on you will improve your structural knowledge. And there is no reason under 90% of circumstances why we need consultants for domestic extensions. You know, I know there's a lot of steel work on domestic extensions now, and that needs looking at, you know, by an expert. But when it comes to timber, I think, you know, most people could use this program together with the loading program and check all timber items, whether they're in the tables or not in the tables. Okay, thanks a lot. Bye bye now.